Okay, so 63, we have two masses connected over a pulley. This whole problem could have been solved with just forces. You could have solved this 2 weeks ago before you ever even learned about work and energy. So here, let's solve this only with work and energy. You should be able to do it both ways though, okay? Because on the AP test, you could be asked to do it with forces or you could be asked to do it with work and energy. So you got to be skillful both ways, okay? So, first question, determine the speed of each object when the two pass each other. So the initial height of object 1 is 4 meters. Where are these guys going to pass each other? When M1 has dropped how far? 2 meters. When M1 has dropped 2 meters, then M2 has risen 2 meters. Okay, so I'm going to draw a line where these guys pass each other. Okay, so right here, like right in the middle. So this line right there, let's just say that's the middle. Okay, so right there is the point where they pass each other. Now we got to talk about our 0 points for potential of gravity. The 0 point, you want to set the 0 point to be at the lowest point for the problem. But here we have two objects, right? So for this situation, what's the lowest point for M1? What's the lowest point for this guy? It's going to be right here, right? It's going to be 2 meters down, this line right here. So this is the 0 point for M1. And then what's this height there? 2 meters. Okay. What's the 0 point for M2? What's the lowest point for M2? Right here. So we have two different 0 points. Now guys, do you have to have two different 0 points? You don't. Like what you could have done is you could have had down here be the 0 point for the whole problem. And it would have worked. You know, you could have done that. But having two different 0 points is going to simplify things a little bit. Does this make sense? Okay. So here's the idea. Mechanical energy 1 initial plus mechanical energy 2 initial plus or minus any work non-conservative equals mechanical energy 1 final plus mechanical energy 2 final. All right, so we got to keep track of the energies of both objects. Okay, work non-conservative. It may at first appear, when you first look at this problem, you might think, oh, we have a non-conservative force, which is true, right? What's the non-conservative force here? Tension. Tension is doing work. So for M2, for this blue guy, is tension doing work in the direction of motion or against? In. So that's positive work. Okay, here, which way is tension doing work? In the direction of motion or against it? Against it. The tensions are equal and the distances are equal. So what's going to happen to the work done by tension? It's going to cancel. So we don't have to worry about the work done by tension. So long story short, do we have any non-conservative forces to keep track of here? No, everything's conservative. All right, so mechanical 1 initial. Any springs in this problem? Nope, so I'm just going to leave springs off. So mechanical 1 initial is going to be kinetic 1 initial plus potential 1 initial. Mechanic 2 initial is going to be kinetic 2 initial plus potential 2 initial. And then over here, this is going to be kinetic 1 final plus potential 2 final. And then this is going to be kinetic 2 final plus potential 2 final. A lot of this goes to 0. All right. Do we start with any kinetic at all? When the problem begins, any kinetic? Nope. So both kinetics go away. We have no kinetic initial. All right. Does object 1, does M1 start with potential energy? Why does object 1 start with potential energy? Because he is above the what? Here's the 0 point for M1 right here. There's the 0 point. Is M1 above the 0 point? Yes. So we have potential of object 1 initial. Does object 2 start with potential energy? No, because where's he sitting? On the 0 point. So we have two different 0 points, which makes it a little simpler. All right, final. Do we have kinetic energy final? Yeah, they're both moving, right? Both objects are moving, so we have two kinetics. Which potential energy is going to be 0? Potential of 2 or potential of 1? Potential of, what did I do here? That's a 1. That should be a 1. So potential of 1 goes to 0. So what we're left with is this. Potential 1 initial plus, wait, what did I do? 2 initial, oh, that was 0. So potential 1 initial, and that's it. So potential 1 initial is equal to kinetic 1 final plus kinetic 2 final plus the potential energy of object 2 final. So this is kind of the master equation for this problem. So now what you do is you plug in. You go, and don't just say M. You got to specify M1 or M2. So this is going to be M1 G H1 equals 1/2 M1 V final squared plus 1/2 M2 V final squared. Hey guys, do we have to specify V1 or V2? Because what do we know about the two velocities? They're the same. The velocities are the same. Okay, then plus M2GH2. Guys, the only thing missing in this equation is what? Velocity. So I'm kind of short on time here. So you solve that for velocity, and you're going to get 3.1 meter per second. Okay? So you do the algebra. Like, so for example, what's H1 here? H1 is going to be what? 2 meters. That's this right here. That's 2 meters. And then what's H2? Also 2 meters, right? Because how high does M2 go up? 2 meters. And then you got the M's. So just do the algebra. Solve for V final. Yo.
Wait, why is for the M1? How come like it's the 2 meter? That's the lowest point.
Okay, so for M1.
Yeah.
Okay, so M1 starts up here, and M1 is going to drop 2 meters. So what I did is I said that this level, this line right here, is the 0 point for M1. So M1 starts out 2 meters above. Okay, question B, very similar. Very similar for B. Now, determine the speed of each object the moment the 5 kilogram object hits the floor. So for this problem, look, the 0 point, I would keep the 0 point as this for both objects, right? Right here is the 0 point, because that's the lowest point for each object. So basically, what's the only energy we start with in this problem? The only energy we're starting with is what? Potential of gravity 1 initial. This guy is the only, there's no kinetics, right? There's no motion. The only energy we start with is potential of gravity for object 1. And then what are the energies we end with? So M2 goes up, M1 goes down. We're going to end with 2 kinetics. So it's basically what we just had. Kinetic 1 final plus kinetic 2 final, and then there's a third one. M2 goes where? Up. So he's going to end with what? Potential of gravity. So all this is keeping track of your energies. Okay, so then you plug in. It's the exact same thing. M1 GH1 equals 1/2 M1 V final squared plus 1/2 M2 V final squared plus MGH2. What's this H right here? 4 meters, right? How high is M1 above the 0 point? 4. What's H2 going to be? 4. How high does M2 go up? 4. What's the only thing missing in this equation? V. So you solve that for V, and you're going to get 4.4 or thereabouts. All right. Last question. How much higher does the 3 kilogram object travel after the 5 kilogram guy hits the floor. So look, so right here, let's say that this right here represents the 3 kilogram guy. Here's M2 right here, right? Is M2 just going to go boop and stop? Right? Because he's in motion. So when the 1 kilogram mass hits the floor, M2 is up here. And what's going to happen? He's going to continue going higher. Well, what type of energy does M2 start with? Kinetic. What does it end with? Potential. What must be true? Those are equal. So you go kinetic initial equals potential final. So that's going to be 1/2 mv squared equals mgh. The m's drop out. So h is going to be v squared over 2g. And what's that velocity? That's the 4.4, right? So h comes out as 1. And so that's from where? That's from here to where it ends, right? That's 1 meter. After the 5 kilogram guy hits the floor, the 3 kilogram guy will go 1 meter higher. What's another way you could have solved that? With kinematic. You could have figured that out with a kinematic. Isn't physics awesome? Different ways of doing the same thing.